My name is Magnus Bakken. I'm a senior research scientist at Predictor, and I'm doing my PhD with NTNU. The topic of my PhD is around using information models to build applications that sort of help you manage physical processes and assets. The topic of my talk is using open standards and open source to drive digitalization. So I hope to provide you with some concrete examples on how to do this, and I think it will fit well with what the other speakers have been talking about. So let's start. My PhD topic sounds perhaps a little bit complicated, but it's really quite simple. And simple ideas can be quite powerful. So this is now, I guess, reiterating the message a little bit from the previous speakers. So as Espen was talking about, when you wired, this is a kind of an application, a monitoring dashboard, the old way, you would do that by sort of manually specifying the tags and doing a quite laborsome process. If you have an information model, then as we've heard, what's going on in industry is that companies and also equipment vendors are supplying or using information models. So what we can do is to look at the information model as a thing which has some adapters. So this is now a little bit RES inspired, I guess. You have a site here and of a wind farm, and then you have some subsites, each with some wind turbines, and all of the wind turbines would have then a converter system that's converting the energy into electricity. And we can look at these converter systems as sort of these adapters. So this is now the USB icon, and you can sort of plug things in here. So what you do then with your dashboard is you make that into a plug, and then a little bit of a sort of a pedantic example is to say that we sort of can multiply now this dashboard with which represents a plug with all of these adapters in our information model, and then we would get sort of 6,000 dashboards. Of course, in practice, you wouldn't do this, but you say that, of course, you have the potential to plug your dashboard into each of the 6,000 units in the information model. So I'd like to show you this in practice. So let's see, going out of the presentation into what's called Grafana. So Grafana is probably the world's most used open source software for sort of monitoring dashboards for time series data. And there is an open source plugin for connecting Grafana with OPC UA, and some clever people at Predictor have extended this to also cover information models, and this is open sourced on our GitHub page. So this is now a simplified example. So we're able to browse a simple information model with a pump house. Let's see, the pump house has some pump trains, there are some pump loops, and there are some pumps here. So, and the pumps has some data associated with it, and then we can browse here as you see that the pump and pump loop 2 also has the same kind of stuff, perhaps not exactly the same. So in any case, this is then allows you to browse the information model, and we can see here that we can connect a dashboard directly to this to this pump. And now this is doesn't fully utilize the information model, but we're at least we're spared the pain of working with tags and this manual stuff. So this is sort of the first example. We have if you look here, we have a panel that displays the incoming pressure of the pump. And we see here that we've connected this to an instance in the UA model. So this is now connecting to the pump house, pump train 1, pump loop 1, and then the pump, and this is now connected to the inbound pressure. So this is, of course, sort of still locked to defining one dashboard sort of for each node in the information model graph, if you will. So so what we've been able to do is to implement this port adapter pattern. And so so this what I'm showing you now is a dashboard that's been, so first we build it for the single pump, and then we adapt the dashboard for sort of generalize it to the type instead. So we can find the same sensors here. This is now the incoming pressure. And if we go here, we can look at how data should be wired to this template. So we see here that now we've selected the type, and we've selected that we'd like to connect this to a signal relative to the pump type. So in OPC UA, you declare then what's called, it's an instance declaration, which is saying what do pumps look like. And pumps can have inbound pressure, and then it would be sort of in this relative path here relative to the pump type. So of course we don't get any data because the sort of the general pump doesn't have data. We have to look at the particular pump. So if we go back now to our browser, we can go into the pump house and we look at the first pump train and we press the first pump. And then we see that we are able to, or in our dashboard mapping, we can say that I want this pump number 1 to be mapped in terms of, by virtue of it having the pump type, we would like to use the dashboard called pump template to display this information. So that means when I use or when I press the pump, this is using the template dashboard from before. So then we can just go into the pump and see that now we have the pressure auto wired from the information model. And also we have the opportunity here to use some nice, let's see if I can successfully scroll, to have some nice process flow diagrams to sort of look at the pressure here. And so this is showing really how you can use an information model to scale a dashboard across a plant or perhaps a portfolio of plants using this port adapter pattern and OPC UA information models. So this plugin is available on our GitHub page right now, so it's possible to have a look. Yeah, so if you press pump 2 just to show you, then of course this is also now using, in terms of it, the pump 2 having the pump type, then we use the pump template and display the information from pump 2. So that was just a short demo to sort of make this a little bit more concrete. Moving on. So now we've looked at applications of the kind of monitoring kind. And there's also the task of, let's say, data engineering, data analytics, wanting to get data from a plant. So what we've found working with customers is that it can be quite cumbersome to get the right data, and this is sort of echoing what Espen said, that you would have to do some emails with a domain expert, and the domain expert would check his Excel spreadsheet or the SAP system or something, some other database, and then come back with a data dump that you then can use for your analytics initiative. So what we've decided to do there is to put the information model in between and make this much more self-service. So that makes it less error prone, and the data analyst is able to sort of get the data they want by using the model. And this is a product we call Data Engineering Suite. And I will now show you a little bit of Python code for the people who don't know Python. I assure you it will quickly quickly pass. But just for those of you who know a little bit of Python, I would like to just show you what this looks like. So this is now the Johan Sverdrup plant that Stefan was talking about. We're sort of connecting to a server here, and we're able to work programmatically with the types from the N-type library that Equinor has open sourced. So let's see. We see that there is a pump here. We're talking a lot about pumps today. So I'm able to use now programmatically the information model and say that I'd like to get the objects of type SDL S95 pump type. So then I get what's called, and now this is for the people who know a little bit of Python, a data frame which is basically a table with the pumps that exist and what variables they have, what data they have. So now I'm just constraining myself to talk about or to look at the circulation pumps, and then I can use the information model again to navigate from the circulation pumps and to get the drivers. So that would be an engine, I guess, or a motor. And then I get then I get the table or data frame of drivers here. So, and then I can also, of course, navigate up again from the drivers in the hierarchy here to get the pumps where these drivers are attached. So this sort of gets you back again. So this is sort of a simple API for data engineers, data analysts that have some programming competence and want to use models for data access. So if I look now at the drivers that have bearing temperature, this is just constraining to drivers having a bearing temperature. I'm able to then ask for historical data starting from 1 hour ago up until now for the bearing temperature for these drivers. And so all of the sort of OPC UA technicalities here in the background with node IDs and this kind of technical stuff, the analyst doesn't have to know about this. The analyst knows Python and knows the information model, knows how the standards for describing this asset. So then they can get some data about the bearing temperature. And as you can see, this data is it's just a sine wave. So it's just some fake data. So that was it for the code. Hope some of you found that interesting. So now zooming out a little bit, if we use Data Engineering Suite or use the information model to specify how we get the data for our analytics procedure or an analysis procedure. And let's say our analysis procedure is made in a way that makes it robust and reusable across our portfolio. Then we have the same port adapter or plug adapter pattern, and we can scale this across a plant, or we can scale it across a portfolio of plants. And this is what one of our customers has done with some analysis analytics stuff they've done to monitor the condition of their plants, and they've been able to scale it to quite a few plants using this method. So it's a nice and simple trick. So this was now sort of for the Python or the programmer. But we'd like to do something also for, there's lots of other people that are interested in data that don't necessarily know Python. So we'd like to make something for model-based data access there as well. And this is now connected to RDS. I won't go into detail on RDS, but I guess you can see you got enough of enough context from Erik to know what we're working on. So this is now a prototype. There's little behind the scenes here. It's mostly a GUI, but we're working on the design and sort of the formal stuff that goes behind such a solution. So the idea here is that the user would press would just use a sort of a wizard or a search functionality to get some data. They might press sort of or say that I want data from such and such a site or such and such a path. So this is now akin to the paths that Erik was talking about in his RDS presentation, or you could say something about the period of time you want data for. So let's pretend we typed in pressure transmitter here, and then we can sort of get this is now the RDS codes for things that are about pressure transmitters, and we can press here and see that. Well, let's look a little bit first, and that there are 2 absolute pressure transmitters. We can select those, and we can say that we can even look a little bit at the description here, because I think these codes are a little bit difficult to remember. So that would be, I guess, useful. And then we can say, okay, there's a pressure transmitter, but I mean, lots of things have pressure transmitters. I would also like to say something about where in my model is the pressure transmitter. Is it in a transforming system? Okay, so let's say I want the pressure transmitter in the transforming system. And the idea here is that we will on the fly formulate a very compact and nice query that actually goes in and gets the data. So moving on, I would perhaps want to say that I'm not interested in all of the signals associated with the pressure transmitter. I might just be interested in the pressure transmitters where something is wrong. So let's say that's what I'm interested in, and then I can specify the period of time. So for instance, for the previous year. So this is just a taste of what we're working on in order to make it possible to use models to access data. So let's see, going back. And then, so this is what I'm now working on in my PhD, is to sort of formalize this query language over RDS information models to make a nice query language in terms of the models that allows you to get data. So this is now a hydropower plant where there is a valve in what's called the penstock. Now. Erik Wiborg knows all about this, and I know almost nothing, so I hope I don't say anything wrong.
You're good for now. This sounds good. Yeah.
Okay. Yeah, I've already corrected the main valve here, so it's in the appropriate place. So there is a transforming system according to RDS in this hydropower plant, which is transforming the energy from one kind to another. And then there is a flow controlling system here, which is sort of the main valve for this transforming system. And then this is now part of IEC 61850, which is describing. So RDS is more about contextualization, and 61850 is more about, can tell you more about sort of the signals and how they are structured in terms. Yeah. So this would then be the signals from the main valve, indicating, so this is the main valve moving now? What's the position in percent? That's the magnitude of the position in percent. And then there is I guess there's a flow through the valve, which might be monitored as well. So this is sort of just a suggestion for a query language that that could sort of allow you to extract data from this, which would then be a sort of a backend for this query visual, or this query wizard that I just showed you. So this is part of a paper that I'm hoping will get accepted. In any case, we will open source the code and some documentation for it before the summer. So we have a GitHub page, and we'll put things there as we move along. So finally, for a sort of a final point, what we're doing here is sort of using models, or putting models in the hands of the users, and saying that the users use the models to get data or to wire dashboards and so on. And this means that you are in some way freeing yourself from technical detail. You're hiding away technical detail, and that means that for things like the data engineering suite, which I was discussing, and this query dialog here, it doesn't matter to the user what the technical implementation is. And for a big company, this can mean that you can change technologies that realize, or sort of change the technology that keeps your time series data without it impacting your applications, which is sort of the an added value here of using models. And this is part of also this low code movement. Some of the benefits of low code and sort of using models is that you don't tie yourself to technology and allow yourself to sort of abstract away technology a little bit. So let's see, was there anything more? Yeah. So we have some prototypes for how to access data in a uniform way. That's not depending on whether you're in an on-prem setting or you're in the cloud. So this is sort of the let's say an advanced term. It's the corollary or the related point to the previous slide, that you can change the database. So that means you can actually also have model portability going from on-premise to the cloud, and that also means what comes with it is application portability. So in a sort of a machine learning or an analytics perspective, you could perhaps train your machine learning models using the scalability of the cloud, and accessing data using sort of in a model-based way, and then you can take your you have portability of that algorithm. So that means you can put it in an on-prem setting without changing the way you access data, which is something we're working on. So some useful links. So this is just the Predictor GitHub page, and also I put in a link for the open source information model from Equinor. So I think with that I say thank you, and we can open up for some questions.
Great, thank you, Magnus. Before we start off with questions, I just want to mention that we're still struggling a bit with getting Petrograph in. So Steve, you will be up next, if that's no problem with you.
Yeah, no problem.
Excellent. We have one question so far for you, Magnus. Many people are worried about data security and ownership. How does, now wait a second, that's the wrong one. Does the data engineering suite work with any type of OPC UA info model? How well does it scale?
Yeah, So that's two questions.
Yes.
Yeah. So it's I mean, in principle, it works with any OPC UA information model. You might want to sort of do some adjustments to make it more user friendly for your model. If you, let's say, have your not everyone is storing their engineering units, let's say, in the same place. So you might want to do some adjustments around things like that. But in principle, it's compatible with all OPC UA information models. And the second question was?
How well does it scale?
So the example you saw was for the Equinor model for Johan Sverdrup, and it's quite a big model. I think it's 1.8 million nodes. And for our other customer, I think that's even bigger. So it's highly scalable in terms of the size of the model, and so that's sort of for navigating the model. It's quite scalable. And also for data extraction, we use a compressed binary format there for extracting data. So it's we haven't had any problems with scale.